In the last class we seen what is acceleration, what is uniform motion, what is uniform circular motion, and what is non-uniform motion. We just completed in the last class. In this class we are going to derive what are motion equations here. These are very important in a problem solving purpose. Solving problems, this topic is, these motion equations are very important to us. So let's see what are the motion equations are important, how to derive that equations. So you know that acceleration having one kind of formula, and velocity is a one kind of velocity also having formula, and acceleration also having formula, displacement also having formula, speed also having formula. But how these quantities are, particularly for example, so I want to find the velocity of a car. I want to find a velocity of a car. So how can you calculate that velocity? So if you want to know the velocity of a car is, so what are the remaining quantities are important to you? I want calculation of a velocity in one situation. So for that we need some other quantities are important, like displacement also important here, acceleration is important here, time is important here. If you want to calculating acceleration, again acceleration having two factors such as a initial velocity and final velocity. You know the what is initial velocity and what is final velocity, and how to take the values of initial and final velocities. That is also important while finding velocity properly. So for example, to finding acceleration of a given situation, of a given motion of a body, for that velocity is required to us. Why? Because that acceleration depends on velocity. How do you calculating directly? You are applying what is the velocity of a car? No, not like that. So we are taking change rate of velocity over there. Like the car initial velocity also required, final velocity also required. From that final velocity, maybe you are subtracting initial velocity with respect of time, and that case will get what is acceleration of a car. It's a process, it's a big process. For a formula is what is acceleration, A is equals to V minus U by T, that is acceleration, sir. But how that acceleration is should be to be calculated. Understand? So for that we are for solving such situations, such cases, here some motion equations are important to us. Understand? So let's see what are they. The first thing is, let's take acceleration here. So acceleration A equals to del V by del T. Acceleration A equals to del V by del T. Clear? Now here del V equals to V minus U. So del V equals to V minus U. How? Since change rate of velocity, that one. So del V equals to V minus U. Now substitute del V into the equation number 1. Say this one, equation number 1. Now let's get A equals to V minus U by T. V minus U by T. So say this equation number 2. Say that equation number 2. So A is equals to V minus U by T. Say that equation number 2. Now the next one is, send this T to this side, at A side. It becomes AT equals to, so AT equals to V minus U. AT equals to V minus U. AT equals to V minus U. Now minus U, this minus U, send at this side, send to here. So it becomes AT plus U equals to V. Therefore V equals to U plus AT. So this is one of the motion equation to us. Say that equation number as 3. Say that equation as 3. Clear? So first one is del v by del t, and from that we just concluded v minus u by t as acceleration formula. Apart from p is equals to u plus at, we drawn from the what? Acceleration. Now see here, for calculating acceleration, initial velocity, final velocity with respect of time, 3 factors are important. For calculating velocity, initial velocity and with respect to initial velocity and acceleration, time also required. These quantities are required. So go to the next one. So v is equals to u plus at. We know what is average velocity. What is average velocity? V plus u by 2. Average velocity equals to v plus u by 2. So but here velocity equals to displacement by time. Displacement by time. Velocity equals to displacement by time. Got it? So now see here, then average velocity equals to displacement by time. Is it possible to writing like that? Average velocity equals to displacement by time? Absolutely possible. Now what is average velocity? V plus u by 2 equals to, what is displacement? S. What is time? T. Okay, v plus u by 2 by equals to s by t. Now from the equation number 1, we know what is v. V plus u plus at. So from equation number, not 1, from equation number 3, from equation number 3, we know v is equals to u plus at. Now substitute the v value into the equation number 4. Substitute that v value into the equation number 4. Do we get? So v as u plus at plus u by 2 is equals to s by t. U plus at plus u by 2 is equals to s by t. Got it? Just what is u, v plus ut here? I just taken v value here. Just substituted v as u plus at from the equation number 3. Got it? So u plus u, 2u plus at by 2. That is equals to s by t. That is equals to s by t. Continues here. So what? We got 2u plus at by 2 equals to s by t. Okay, that equation only I have written once again here. Okay, see, now simplify it. 2u by 2 plus at by 2. 2u by 2 plus at by 2 is equals to s by t. Now here 2 cancel. 2 cancel. What we get? u plus at by 2 equals to s by t. U plus at by 2 is equals to s by t. Now multiplicate this t to u plus 8, nothing but cross multiplication. Okay, so t into u plus at by 2 equals to s. So t is, I sent here, it becomes t into u plus at by 2 is equals to s. Got it? So now multiplicate each factor here. U into t, ut plus u into half at by 2, u t into half at square by 2 equals to s. So a small simplification, ut plus half at square is equals to s. Therefore s is equals to ut plus s is equals to ut plus half at square. This is a motion equation for displacement. Do you getting how factors are coming here? Like, so motion equation for acceleration, motion equation for velocity, motion equation for displacement. So s is equals to ut plus half at square. These are the three, and let's see more one. From equation number 2, see, a is equals to v minus u by t. So I just drawn from here t. What is t value? For that I am sending t to this side. So it becomes at equals to v minus u. Okay. So now I want t equals, send this a to this side, v minus u by a. This is a function, this is a formula for t. T is equals to v minus u by a. Got it? Now average velocity. Let's consider average velocity once again. So what is average velocity? So average velocity equals to displacement by time. Displacement by time. Once again consider that average velocity. What is average velocity? V plus u by 2, v plus u by 2 is equals to s by t. Is equals to s by t. So v plus u by 2 s by t. So what is t value here? V minus u by a, no? So substitute this t value into the water, this. So it becomes v plus u by 2 equals to s by, what is t value here? V minus u by a. V minus u by a. So now do cross multiplication once again here, or else not cross multiplication. Send this minus v minus u by a to here. So v plus u by 2, v plus u by 2 into v minus u by a. V plus u by 2 into v minus u by a equals to s. Equals to s. Now 2a, send this 2 into a this side. So send this here. It becomes v plus u into v minus u is equals to 2 into a, 2a, 2a into s, 2as. 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 Now see here, v plus u into v minus u. What happens? V square minus u square is equals to 2as. How do you know this? A plus b into a minus b. A plus b into a minus b equals to a square minus b square. We know this formula. Apart from that, v square minus u square equals to 2as. These are called motion equations. These are called motion equations. What are they? A is equals to v minus u by t, v is equals to u plus at, and s is equals to ut plus half at square, and v square minus u square equals to 2as. These are motion equations. What? These are motion equations. Clear? What are motion equations? Are 3. So just remember them. So A is equals to v minus u by t, and v is equals to u plus at, and s is equals to ut plus half at square. V square minus u square equals to 2as. These are the motion equations. Very important in further studies also. In intermediate first year, so the first half portion in intermediate complete depends on these topics. In physics, not on all subjects. So in on physics, these topics are mandatory in intermediate first year. Okay, that's what important. Very important. Let's see one experimentation is there. Okay, we discussed different types of examples, different types of topics from this lesson, like translatory motion we seen, and circulatory motion we seen, and like different types of motions we are observed and we given values for. So does the motion on inclined plane, so is it uniform or not? Motion on inclined plane. Let's take the word one experiment here to confirming the given situation or the given experiment is uniform or not uniform. And we know that before explaining that, on these inclinal planes, the motion on inclinal planes, Galileo Galilei, very famous scientist. So he was done many experiments and many theories, many attempts he was done on inclinal planes. So what is the motion of a body on inclined plane? On that, Galileo given some contributions to us, like what is the exact state of object, how object change that position. So what are the factors are influence the changing of object. So on these aspects he was given many contributions. We will continue next class about this, about Galileo and his theories. We will continue in next chapter in laws of motion. But particularly what we are going to do right now, so we are going to prove, we are going to show, so on inclinal planes the object may be on inclinal plane I am talking about. So on that time object comes down on the slope where the slope is occurs, and that path only object can rolls out. So when the object is on the plane of an inclined, what is the motion of object here? Is it uniform or non-uniform? How it is possible? Let's assume some activities here. So talking about inclinal plane here. Okay, let's see that. So important these are, just keep in your brain. What is our aim? Motion on inclined planes. What is our aim? Motion on inclined plane. Motion on inclined plane. So let's see what are the materials are required for doing this experiment. So motion on inclined plane, what are the materials are required for doing this experiment? So that is very important. Materials are very important to us. Two pipes with 1 meter of length, two pipes in 1 meter of length, two pipes are having 1 meter of length. Next, steel plate. Next, metal ball. So steel plate, metal ball, stopwatch, next some books. So these are the mostly required materials for doing this experiment. So first of all, why books are we are taking here? Books are taking for the what? Making arranging inclinal plane. So for that I am consider books here. So okay, key books as shown on the figure. Okay, so now by using keep two pipes in a contact like a track. Make it, just we are making track by using two pipes, like track wise, we are making that as a track wise. So now place one steel plate here. Pipe track. This is our inclined plane. We set up inclinal plane by using this. Now place one metallic ball on the track of pipes. Place one metallic ball on the on the tracks of pipe. Okay, clear. Now just simple thing. If you roll this metal ball from the A position and the B position is plate. So when this leave from this, the metal ball should be taking covering the path of track. When it reaches to down, when the path is completed, the metal ball go and hits the water steel plate, and that time steel plate makes some sound. That is our like a water 2 plus T3 by 3 average time. And this one is u square by 2a. Just calculate what is u square by 2a here. Not u square by 2a. No, not that. So no need to this. So just calculating average speed only, no. So we will do that in next attention. In problem solving, I'm going to explain what is that. So here first attention I am using metal ball. So serial number 1. So first attention metal ball. What is the distance it is covering? 1 meter of distance it is covering. So in 1 meter distance, first attention, first one, each and every object I am measuring 3 times. First attention it covers, for example, x meters of distance. In second also, third also it covers what? X meters only. So x plus x by 3, nothing but 3x by 2, 3x by 3. So average speed is what? X only for that. Next, in second attention, I took one coin. So it also covers 1 meter of distance. So in T1, what is the time taken for first attention? Remaining attentions also, what is the time taking for remaining attentions also? Similar or not? Similar. Why? Because same track, same distance, same time. So overall we can say that, for example, for coin y. In 3 attentions is covered same distance. Maybe you are getting some doubt why you are using alphabets here. So example, first 2 seconds, 2 seconds, 2 seconds. So 2 plus 2 plus 2 by 2, nothing but what is the average speed of that? 2 only. What about the coin? 3 seconds, 3 seconds, 3 case. Average is what? 3, like that. So overall we can conclude by using this experiment, and on inclined